Hi, my name is Everett and I'm a student in medical engineering here at MIT. Today I want to tell you about one of my research projects studying the mechanical fracture of stents. Stents are devices used to treat heart attacks. They're implanted inside the heart to open up the blood vessels. My research project is figuring out what happens to these stents when they're implanted in patients for many years at a time and eventually break. The coronary arteries undergo bending, compression, twisting, and radial pulsation, and all of these different components together can lead to stent fracture. I created a machine to simulate these forces and study how stents break on the bench. First, we insert the stent into a sample holder that limits any mechanical input prior to the test. We use the fixture to insert the stent into the machine. The machine translates the linear up and down motion into symmetric multimodal loading. It also allows for constant monitoring of the integrity of the stent throughout the test. Then, using high-resolution imaging and fracture detection equipment, we can see how the stent fractures, and study how small fractures lead to complete breaking of the stent into two pieces. This information helps us understand how stents fracture, and with computational models and animal studies, we can begin to understand the complications these fractures can cause. Our work is important in understanding the potential complications of stent fracture, and this is important for many different people, including clinicians who want to manage patients with stent fracture, companies that want to come up with new designs of stents, and finally regulatory agencies who need to understand safety and efficacy of these devices.